Hello everyone, I want to use this video to show you more instructions on Lab 5, okay? Air mass fronts and severe weather. So you can see in the first question, it's important to read the question carefully, okay? So that is the two hypothetical weather maps, map A and map B, okay? In northern hemisphere. Okay, so your coral source should be to the right? So using the standard front symbols, okay, in our lecture you will learn the standard front symbols to draw in position of front on each map. Okay, indicate is a cold front or is a warm front. Okay, to determine the cold or warm front, you need to first locate your air masses. Okay, locate your cold and warm air masses on the map. So you may use the temperature readings in the standard station model. So what it is, that basically is this bubble. Okay, so here, this is your station. Where it is, it's a weather station. It's never move. Okay, here is your wind symbol. Okay, wind direction and wind speed. You can read it. On the top, this number, that is your current temperature. Okay, and down here, this number is your dew point temperature, like you learned in our lecture. Okay, so it's very important to use those two numbers. Okay, actually temperature numbers only, to tell the air mass is warm or is cold. Okay, and also based on the definition of air mass they move together. So the wind, in other words, the wind in one air mass, they should move to the same direction. So that is the key to figure out this question. Okay, so you're in one air mass, you only have one direction. Okay, so that is a hint to you. Okay, same thing here. Okay, and once you figure out where is the warm air mass, where is the cold air mass, you just draw the boundary. The boundary will be the front. Okay, but which one is stronger? Okay, the wind towards this boundary with greater angle, more direct, like 90 degrees, that air mass will be stronger, and therefore that the front will be cold if the cold air mass is stronger, or warm if the warm air mass is stronger. Okay, so that is a hint to this question. Alright, the second one basically asks you to draw the mid-latitude cyclone. Okay, we have an example on our lecture slide and also in your textbook. Okay, there's a video to show you on our study guide to show you how this thing form. It's a very important concept. I will go over that in our lecture, our lecture meeting. Okay, so you want to read the question carefully, label the cool air sector, warm air sector, where they are, and use the arrows to indicate the wind, again, in northern hemisphere. Okay, in northern hemisphere, figure out your coral source, and you must use the standard front symbols to indicate the type of the front, those two lines, okay, and to which direction they are moving. Okay, so refer to your lecture, presentation, your book, okay, whatever have you, and also our study guide page. Okay, once you figure it out, here I want you to indicate, use direction. Okay, like north, from north to south. Okay, from north to south or from the east to west, things like this. Don't say from the right to left, from the left to right. Okay, as a geographer, we need to know directions. You are the map. Okay, and then you can see this is the cross cut of this mid-latitude cyclone from the top. So I want you to figure out at which point is more likely to see cumulonimbus cloud and which point is more likely to see nimbostratus cloud. Okay, so which location pick the best location? Okay, and how do you expect the air pressure and the temperature change at D, okay, before and after the passing of the front, and explain. Okay, so first you need to figure out it's a cold front or warm front. Okay, to which direction it's moving. Okay, indeed, give you a hint, moving to this direction. Okay, and before it move to D, how the pressure is low, is high. Okay, when it's passing, it's low, become high. After passing, become low, become high. Okay, so you need to figure it out and explain why. And oh, this is the fun part. I need to change the date. I actually have a new map for you. Okay, so you can see this should be the January 2021. Okay, January 2021. Okay, January 28th, 2021 is shown below. That day we have a huge storm. Okay, remember there's a well-developed mid-latitude cyclone centered here. I need to change this part. Sorry, this is from last semester. Okay, but we have a new one. Okay, on the map you will see a code. You see a cold front moving into Southern California. Okay. It brings us a lot of rain and snow. I need to check the number, how many inches. Okay, so this is the surface map. I got this map from here. Okay, so this question basically is provide the opportunity to read the station model. So it's very important to understand station model. Okay, so I want you to examine two locations, two cities, Los Angeles and Santa Maria. Why? Because one is behind this cold front, one is in front of this front, because you can see your front, the cold front, moving to this direction, right? Southeast direction. Okay, so I want you to describe the weather conditions in Los Angeles by reading the temperature, dew point temperature, wind speed, how many knots, your wind speed is here, okay, and direction, again, direction from which direction to which direction, current pressure, okay, remember how you recover the current pressure, okay, 136 is not the final answer. Okay, watch the videos and read the study guide. You will see how to recover this number. Okay, and pressure change in the past 3 hours. You will read it here. Okay, you can see it's negative, means it's decreasing. Okay, but 23 is not the answer. Okay, you need to divide it by 10. I give up your answer. Okay, and how would you expect the weather in Los Angeles in next 12 hours? So you can see the cold front is moving in. Okay, the cold front is moving in. Then in the next 12 hours, describe what Los Angeles will experience. Okay, when this cold front is passing, after this cold front is passing. Okay, and same thing to Santa Maria. Okay, how would you expect the weather in Santa Maria in next 12 hours? Okay, and you have another stationary front up there. Here, this is a stationary front. Okay, you can see the cold front symbol and warm front symbol on the two sides of this line, right? Okay, so that is over, Idaho, Montana, right? these places. Okay, so again, I want you to examine two places affected by the stationary front. One is on the cold air mass side is browning in Montana, and the other one is in the warm air sector side. Okay, it's Helena in Montana. Again, read those station models. Okay, and predict the weather at those two locations. Okay. All right. The last one is a very fun part. Okay, it's a fun part. It's a hurricane analysis. So you're going to click on this link to go to our hurricane tracks center. Okay, historical hurricane tracks center. Here, I want you to type in Katrina. Okay, 2005. Okay, you can see you have a lot of Katrina. I want you to examine this one, which hit New Orleans so heavily, right? You still remember that. Okay, so you can see here, once you are here, you will see there's a track of Katrina. And when you click on this icon here on the left side, you will see the strength. Okay, you will see the strength. The bubbles, the color, and the size actually indicate the category. Okay, so down here you will have a chart to show you the wind speed. Okay, read from this side, wind speed, and also the pressure at the eye wall, the center of this hurricane. Okay, and you will see, oh, it's a very interesting relationship between those two, right? For example, when the pressure, okay, when the, okay, so when the pressure goes down, okay, to the highest strength, okay, then you can see the wind, okay, how that changes. Okay, how that changes. I cannot hold it, but you will see. Okay, you will see the wind speed and pressure, how that change together. Okay, and when and where it changes. So you can see, well, the strongest strength you can see here, category 4, category 5, category 3, category 5 is right here. Right? Okay, so category 5, where it is, almost hit New Orleans. Okay, but once it hit New Orleans, after, you can see the strength start decreasing. Okay, you learn hurricane in your textbook, right? Okay, then explain why. This basically is this question. Okay, so those are the instructions. Okay, I showed you already, and I want you to zoom into New Orleans like this part. Okay, you can see the bubbles, show you the location of the hurricane and the strength. Okay, and let's see, okay, what's the category ranking? Okay, right before it made landfall to New Orleans. Okay, what was the maximum category and where it is? Okay, and what happened to Katrina's strength as it moved north inland, and why did this happen? As it's decreasing, right? The strength decreasing. Why? Okay, think about what is the energy source for hurricanes. Okay, and in the panel you will find a graph showing the wind speed and pressure at the eye wall at different time. Okay, hover over the track. Hover over, when you move your mouse here, you will see where it is. Okay, you will see where it is. You can see here is a bubble here to show you. Okay, and you will see when, the question is when and where the Katrina reached the maximum wind speed. Okay, what's the pressure at the eye at that moment, and what's the relationship in what this describe how those two pressure variable changes together. Okay, so that's it. That is this lab. Okay, you can see a lot of hands-on. Finally, we understand the weather. Okay, so that is this lab. I hope this video can help you answer the question. Okay, all right. So I will hold extra office hour on Thursday evening to answer your questions. But before you come, please at least read through. Okay, bring your questions to our lab meeting. Okay. Okay. Bye for now.